Okay, we are looking at a question on work, energy, and power. Question 14. The diagram, which is not drawn to scale, shows a vehicle with a mass of 1,500 kilograms, starting from rest at point A. So at point A, we know that VI is 0. That is at the bottom of the rough inclined plane. Point B is 200 meters vertically above the horizontal. Then we are given the total work done by force F that moves the vehicle from point A to point B in 90 seconds is 4.8 times 10 to the power 6 joules. Okay. The first question, define the term non-conservative force. Okay. A non-conservative force is a force for which the work done in moving an object between 2 points depends on the path taken. Okay. 14.2 is force F a conservative force? Force F, we know that is an applied force. So an applied force is a non-conservative force. So the answer is no. Okay, 14.3, calculate the average power generated by force F. And then force F, what do we know? We know the work done by force F and we know the time interval. So we can use the formula P is equal to work divided by the time interval, which is 4.80 times 10 to the power 6 divided by 90. Okay, and that gives us 53,333.33 watts. Okay, and then question number, okay, before we go to 14.4, I mean, the speed of the vehicle when it reaches point B is 25 meters per second. So that will be our VF, which is 25 meters per second. Okay, state the work energy theorem in words. Okay, the work done on an object by a net force is equal to the change in object's kinetic energy. So that's the work energy theorem. And then 14.5, use energy principles to calculate the total work done on the vehicle by the frictional forces. We can use work energy theorem. We can use work done by non-conservative force. And I think that will be quicker. We can say WNC is equal to change in EK plus change in EP. And there are two non-conservative forces here. We have the frictional force and we also have the applied force. So it's work done by the frictional force and work done by the applied force. So work done by the frictional force is unknown. I'll just write WF. And then the work done by applied force was given as 4.80 times 10 to the power 6 is equal to change in kinetic energy. It's half mvf squared minus half mvi squared. Change in potential energy is mg final height minus mg initial height. So we have WF plus 4.80 times 10 to the power 6 is equal to half times the mass is 1,500 and then multiply by final velocity is 25 squared. Since initial velocity is 0, this is just going to be 0. So that will be just minus 0. Plus for final final potential energy, it's 1500 times 9.8 times the height, which is 200. Initial potential energy again, since the initial height is 0 at point A, this is also going to be 0. So that will be minus 0. Okay, so we have WF plus 4.80 10 to the power 6 equal to, let's just put that on the calculator. So that will give us 3,408,750. Then to get the work done by the friction, we're just going to transpose, right? And then the final answer will be, let's subtract 4.8 times 10 to the power 6. And that gives us minus 1,391,250 joules. So that's the end of that question.